So welcome to Electronics Shikshalaya, and you are watching the Digital Electronics lecture series. And today the topic of discussion is the difference between the latch and flip-flops. Okay. So latch are the sequential circuit from which the flip-flop are constructed. Okay, and the flip-flops are the sequential circuit, okay, from which and other sequential circuits like counter and shift register can be constructed. So latches and flip-flop both can store one bit of memory elements. So latches are means work by the enable signal, while the flip-flop works by the use of the clock signal. Okay. And that latches are actually level sensitive devices, okay, and flip-flops are edge trigger devices. Okay. Let me take you some examples. So latches basically, for example, uh, you have the transparent window. Okay, so whatever you can see outside when this shade is open. Okay, or there is a door. You whatever whenever the door is open, you can see everything outside. So this door is like a means enable signal. Whenever this door is open, you can see everything what are happening outside. Okay, so this is the example level latches. Similarly, flip-flop is like a camera shutter. Okay, so where it captures the image at exact moment when you press the camera button. That camera button is like a this is a clock signal. Okay, whenever the camera button is clicked, you can click the picture, or it is like a snapshot. Yeah, whenever you can take the snapshot of that image, you can see the or you can capture the image. Okay, so that is like a flip flop. So these are flip flops are like it is a specific moment. Okay, you can capture the images. Okay, so it is usually flip flops are there is the clock. It is the clock enabled signal. Whereas the this latches are basically triggered by the enabled signal. Okay, and it is the latches are known as your label trigger signal, and the flip flops are the called the edge trigger signal. Okay, basically the latches are built by using the logic gates, and flip flops are can be built using the latches. Okay, so let us see the details between the latch and the flip flops. Okay, so latches are basically it is a bistable element. Okay, so bistable means it is the two stable states. Okay, so logic one and logic zero. Okay, so that is why it is the two stable states are there. Okay, so a digital memory circuit is obtained by the cross coupling of two node relays. Okay, so basically the digital logic circuit, memory circuit, can be obtained by cross coupling of two node relays. So what is cross coupling? The cross coupling means the output of each gate is connected to the input of the other gate. Okay, or this is the there is a feedback connection that is called the cross couple operations. Means the one output of one gate is connected to the input of the another gate. Okay, so that is the cross coupling operation. Okay, so let us see the diagram. So this is the that is the basic bistable element. Okay, so you can see the output of this gate, that is gate number one. Okay, output of this gate number one is connected to the that is the uh, input of this gate number two. Okay, similarly the gate number two in output is connected to the input of gate number one. Okay, so that is the called the cross couple operation, where the one gate output is connected to the input of the other gates. Okay, so this is the cross couple operation, or there is a feedback from output to the input. Okay? So the circuit may be there are two stable states. One is your that is the out q equal to 0, and another one is your q equal to 1. Okay, so that q equal to 0 that called the zero state. Okay, so it will store the digit 0. Similarly, when q equal to 1, that is the called the q state, a 1 state. Okay, so when q equal to 0, q bar will be 1, and when q equal to 1, q bar will be 0. Okay, so there are two stable states. One is your 0 and another one is your 1. So let us see how it holds the data. For example, suppose the a value is 0. Okay, the a value 0 means What will be the out Q? So it is a NOT gate. So if A is 0, this output will be 1. Okay. Similarly, this 1 is connected or Q is connected to the B. Okay. So this is 1, B will be 1. So this B, that is the input of the gate number 2. Okay. So this 1 means the output will be 0. Okay. Similarly, this 0, this QR is connected to the A. So 0, it is 0. Okay. So 0, 0, what will be the output? 1. Okay. So this 1 is true for a some duration of time, that Q equal to 1. Okay. So or QR equal to 0. Okay. So that is why it log the information for a certain event as long as other data comes in. Okay. So that is how it means log the information. Okay. For a some time. Okay. For example, suppose A equal to 1. So what will happen? A equal to 1 means what will the output of this gate? So this output will be 0. Okay. So Q equal to 0. Similarly, this Q is connected to the this input B. So that is 0. Then what will the output of gate number 2? That is it will be 1. Okay. So again, this 1 is input of the means input A. Okay. Then it repeats. Okay. As long as another data comes in. So Q can be 1 or that is the or U can be 0. Okay. If Q equal to 1, that is the 1 state. If Q equal to 0, that is the 0 states. Okay. So these data are true for a long duration, some duration of time. Okay. So it will hold the data for some time. Okay. That is the how it stores the data. Okay. So these outputs are true for a long time. Okay. So this information is locked. So as I have told you, the information is locked or latched. Hence, this block is called the latch or 1-bit memory. So it can store only 1 bit. Okay. So that is why this is called the 1-bit memory cell also. Okay. This latches you can see it is a 1-bit memory cell or 1-bit memory element. So this has two stable states. One is your 0, another one is your 1. Okay. So these states are stable and consistent with interconnection. Okay. So this is all about your latches. Okay. So latches are basically that is the rely on the cross couple operation. Okay. So means output of one gate is connected to the input of another gate. So this is like a feedback connection. Okay. But output is connected to the input. So this will log the information for some duration of time. Okay. That is how it stores the information. Okay. So this is the latches. So let us see what is the example means difference between latch and the flip flop. Okay. So latch, I have told you the latches are the basic building blocks of sequential circuit, but is built using the logic gates. Okay. So latches are built using the logic gates. Okay. And what are the flip flops now? So flip flops are the again it is a basic building blocks of sequence circuit, but it can be built using the latch. Okay. So latches are the basic memory circuit. It can be built by the use of the latches. Sorry, flip flops are the basic sequential circuit that can be built by the latches. Okay. Similarly, this is the logic diagram of a latch. Okay, so you can see over here. So then this is the this NOT gates can be means designed by the help of the universal gates. So this is our gate number 1. This is the gate number 2. Okay. So this is there is a cross couple of operation when the output of one gate is connected to the input of the another gate. Similarly, this output also connected to the input of another gate. Okay. So this is the logic diagram of a. So this is can be built using the logic gates. Okay. But the flip flops can be built using the latches. So basically, this is the latches. Okay. And also we have the logic gates also over here. Okay. So this difference is that that can be built using the logic gates, but in the flip flop can be built using the latches. Okay. So you can see there is a clock over here. There is a clock signal. Okay. So what is that? There is no clock in case of a latch. Okay. But in case of a flip flop, we do have a clock or clock signal. Okay. So clock signal, as I have told in the previous class, is that the clock signal is a periodic square waveform. Okay. So the output change state according to this clock signal. Okay. So it is a means periodic square waveform where it has the 50% of duty cycle. Okay. So 50% duty cycle it has. Okay. So means the 50% time the signal is on and the 50% time it is a off time and on time, you can say. Okay. So there is a clock in case of the means this uh, flip flop, but we don't have any clock over here. Okay. That is the means latches and flip flops. So we use clock in the flip flop, but we don't use any clock in the latches. Okay. But it can be triggered by a enable signal. Okay. So if there is no clock, means it is a asynchronous sequential circuit. Okay. If there is a clock, so it is called, we call it the synchronization. Means clock is used to synchronize the information. That is why it is a synchronous sequential circuits. So it can be used in the synchronous sequential circuits. So let us see again. The latches are the sequential device that checks the input continuously. Okay, and change the output according to the any time independent, that is the clock signal. So it is the independent of any clock signal. But in the case of flip flops, it has the clock signal is there. Okay, so it samples the inputs and change the output is determined by the clock signal. Okay. So this is the logic symbol of the latches. So you can see there is a enable signal is there. Okay, this is the SR latch, you can see. So there is a enable signal is there. So the output can change state whenever there is an analog signal, but in this case this is the clock signal. So you can see there is a clock. This is the clock is called the clock symbol. Okay, so it the according to the clock pulse the output can change. Okay, so these are the logic symbol of latches and flip flops. So latch, as I have told you, latch works by the use of the enable signal, okay, whereas the flip flop works by the use of the clock signal. Okay. So it is simple to design, latches are simple to design, but in flip flops are complex to design as compared to the latches. Okay. The power requirement is less in case of latches, and the power requirement is more in case of flip flops. Okay. And less number of gates we are using in case of latches, and we have more number of logic gates in case of flip flops. Okay. The latches are faster as compared to the clock. I mean, as compared to flip flop, as we don't use any clock over here, and it is slow because of the more number of gates. Okay. So again, the latches are the label trigger device. Okay, and the flip flops are the edge trigger device. So what is label triggered and what is edge triggered? You can see. So this is the label trigger device. Okay, so label trigger means, as you can see, this is the positive level. Okay, this is for the labels. Okay, so the means latches can change the state whenever there is a label. So it is a binary, means 1 or 0. Okay, you can see whenever this is the one level or logic high level. Okay, so whenever there is a positive level, it can change the state. Similarly, this is the negative level. Okay, negative level means binary 0. Okay, so whenever there is a logic 0, it can change the state. Okay, so that is the known as label trigger. It depends upon the this positive level or it can be negative level. Similarly, the flip flops are edge trigger device. Edge trigger you can see over here. Edge trigger means there is a edge means it is going from low to high. There is a transition from low to high in this case. So positive edge is the transition from low to high, or it is a rising edge. So whenever it finds the rising edge, the output can change the state. Similarly, we do have a negative edge. Negative edge means there is a transition from high to low. So whenever there is a transition from high to low, this is called the falling edge. Okay. So whether there is a falling edge of the clock, it can change the state. So that is why it is known as the edge trigger device. So latches are the label trigger device, whereas the flip flops are the edge trigger device. Okay. So as I told you, the latches are the fundamental components of all the flip flops. Okay, and flip flops are fundamental components of shift register and counter. Okay, so these are the flip registers and means shift register and counter. Okay, the basic components are in this case we are using the flip flop. Okay. So these are the basic difference between the latches and flip flops. Okay. So we do have the latches, that is RS latch, D latch, okay, JK latch, and we also flip flops. We have that is the RS flip flop, D flip flop, toggle flip flop is there, JK flip flop is there. Okay, so these are the types of flip flops. The main difference between the latches and flip flop is that the latches can be built by the logic gates, and the flip flops can be built by the latches. And also the latches are the means level triggered device, and flip flops are the edge triggered device. Okay, so flip flops are can be enabled by there is a clock pulse. Okay, but we do have any means we don't have any clock pulse in the latches, but we in case in the latches we have the enable signal is there. Okay, so that is the difference between the latches and flip flops. Okay, so these slides are prepared by using these two. There is two books. One of the book is from Anand Kumar from PHI publication. Another book is from P Raja for SkyTech publications. Okay, so that's all. So thank you all. Stay connected to that channel. So if you have any doubt, you can comment me in the comment box. And thank you all. So see you in the next video. So thank you all.